Welcome. So this is CIE October November 2007 Statistics Paper 6. There are 7 questions in that. We shall try to solve all the 7 questions over here. So starting from the question number 1. So this question number 1 is from the concept called as coding. So we have the coding. The coding done is minus A. So from each of the data, an A has been subtracted. So we will make 2 columns. One is original and another one is coding. Now for the coding, from each one A has been subtracted and added, and it's given as that 73.2. So, and there are 24 observations, n is equal to 24. So I'm going to find the coded mean. Coded mean is just divide sigma x minus a divided by n, which gives me nothing but what, minus 73.2 divided by 24, which is minus 3.05. This is the coded mean. So as said in this in the beginning, the coding is nothing but what, so subtracting minus a in this question. So therefore I have to get back to the original mean. How do I get back to the original mean? So if at all I have the original mean, the coding also has been done for the original mean is minus a. If you subtract a from each observation, then the mean also gets subtracted with a. So original mean minus a is equal to the coded mean. So original mean is given in the question as 8.95. So 8.95 minus a is equal to minus 3.05. So I do that one and get the value of a, which is 8.95 plus 3.05, which is a value is 12. So if at all the coding is done, the same effect of the coding, whether it is addition or subtraction, only for addition or subtraction, the mean also get added or subtracted. Over here it is subtracted with a, so the mean also gets subtracted with a. So original mean minus a is equal to minus 3.05. From that I get the value of a. Now that comes to the end of the first part of the first question. Now what is being asked? Now it is being asked as the find the standard deviation of x. So standard deviation does not changes irrespective of the coding, whether it is addition or subtraction. So I write the formula sigma x minus a whole square upon n minus coded mean whole square. When you're taking it out of this coded mean whole square, so I take the values which are given in the question, which is 2115 divided by 24 minus of minus 3.05 whole square. When I simplify by this calculator using the 3 significant figures, I'll be getting it out as 8.88. That's going to be the answer for question number 1. Now coming to question number 2. The probability random variable x takes the values minus 204. So I quickly draw a probability distribution table. Over here I am drawing a table. The values are minus 2, 0 and 4. Negative 2, 0, 4. This is x, and probability of capital X is equal to x. And when it is negative 2, it is 2p. And when it is 0, it is p. And when it is 4, it is 3p. So this is the probability distribution table. We know that sum of all probabilities is 1. So 2p plus p plus 3p is equal to 1. So 6p is equal to 1, p equal to 1 upon 6. So I got the value of p as 1 upon 6. Once I get p value as 1 upon 6, what am I going to do to this? I am going to erase these values and rewrite with the p value. So it is 2 upon 6, 1 upon 6 and 3 upon 6. That's going to be the new probability distribution table. Now find the expected value and the variance of x. So expected value of x is nothing but what formula is sigma x px. Just multiply the x with the probability, respective probability, and add them all. 1 upon 6 plus 4 times 3 upon 6. You can use the calculator to get the value, and I'm directly writing it out. It should be 4 upon 3. If you want to write in 3 significant figures, it is 1.33. Next is nothing but what? It is variance of x. Variance of x is nothing but what it is? Sigma x square p of x. So just square it and multiply with the probability. So what you should do? So and subtract the expected value of x whole square. So it becomes minus 2 square times 1 upon 6 plus 0 square times 1 upon 6 plus 4 square times 3 upon 6 minus 4 upon 3 whole square. So this should be giving you 68 upon 9 on 3 significant figures, 7.56. That's going to be the answer for the second part. Now the third question. The 6 digits 4, 5, 6, 7, 7, 7 can be arranged in given different ways. Give many different 6-digit numbers. How many different 6-digit numbers can be made? So we want to make 6 different numbers. 1, 2, 3, 4, 5, 6. So I have 6 places to be filled with 6 digits. 6 places can be filled with 6 digits in 6 factorial. But out of these 6, you can see that 3 are identical. 3 are identical. So whenever 3 are identical, we divide with 3 factorial. So 6 factorial divided by 3 factorial, which is going to be 120. So that's going to be the answer for the first part. How many of the 6-digit numbers start with odd digit and end with an odd digit? So we have the numbers 4, 5, 6, 7, 7, 7. So they should start with an odd number. 1, 2, 3, 4, 5, 6. So it can start with 5 and end with 7. When it starts with 5 and end with 7, or it can start with 7, end with 5, or it can start with 7 and end with 7. So these are the only 3 possible ways of starting with an odd number and ending with an odd digit. So starting with an odd digit and ending with an odd digit. So we take case by case. So the first case, 4, 5, 6, 7, 7, 7, starting with odd and ending with odd. So 5, 7. So if 5 is done with, 7 is done with, so what am I left over with? I am left over with 4 digits, and again I am left over with 4 places. So it can be done in 4 factorial. But again, what is happening is 2 are identical. 2 are identical. So whenever it is identical, so divide with 2 factorial. So 4 factorial divided by 2 factorial, which becomes 12. This is case 1. Now case 2, 4, 5, 6, 7, 7, 7. So what am I doing? Starting with 7, ending with 5. So 7 and 5 are done. So again I am left over with 4 digits, and it is to be filled in 4 places, or 4 places to be filled with 4 digits. 4 factorial. Again you can see that 2 are identical. When 2 are identical, divided by 2 factorial, which gives me 12. Now coming to the finally the third option, 4, 5, 6, 7, 7, 7. Starting with 7, ending with 7. So I cancel 7 and 7. 7, 7. So again, now I have 4 places to be filled with 4 digits. It can be done in nothing but what? 4 factorial, and none are identical over here. When nothing is identical, so no need to divide by anything. So it's just 4 factorial, 24. So the total answer should be 12 plus 12 plus 24. 12 plus 12 plus 24, which is going to be nothing but what? 48. Question number 4. The random variable x has a normal distribution with mean 4.5. So mean is equal to 4.5. Then he has given that probability of x greater than 5.5 is equal to 0.0465. Whenever we have to greater than to lesser than, so we do 1 minus 5.5 minus mean is 4.5. By standard deviation we don't know, is equal to 0.0465. So it is greater than is given. Whenever greater than to lesser than, we have to convert. What we are supposed to do? We have to use 1 minus. So I have done 1 minus. Now bring the terms on one side. Probability of z less than 1 upon sigma is equal to 1 minus 0.0465. 0.4065. So I quickly do by that calculator. So it becomes 1 minus 0.0465 gives me something around 0.9535. So z less than 1 upon sigma is equal to 0.9535. Now we will be seeing with the table this value 0.9535. is 1 upon 1.68. So 1.68, so sigma is equal to 1 by 1.68, which gives me nothing but what sigma value 0.5952, but I have to write in three significant figures 0.595. That's going to be the answer. So that is the standard deviation. Now coming to the second part, find the probability that a random variable x lies between 3.8 and 4.8. So probability of x lies between 3.8 and 4.8. So it is being asked what is the probability of x lies between 3.8 and 4.8. So whenever we have lies between two things, so the second one minus first one, probability of x less than 4.8 minus probability of x less than 3.8. So probability of z converting into z less than 4.8 minus mean is 4.5, and take the standard deviation, full calculated display or four significant figures, that is gives you much more accurate answer. So I am taking 0.5952 as my standard deviation. Next, what am I going to do it out is, give me a moment. So yes, so there, then what it says, z less than 4.5 minus 4.8. 4.8 minus 4.5 divided by the standard deviation, this value is going to be nothing but what, 0.504, minus this value is z less than negative 1.176. Again, whenever we have negative value, in order to convert negative to positive, so what am I going to do? I am going to write it out 1 minus. So probability of z less than 0.504 minus 1 minus probability of z less than 1.176. So probability of 0.0504 is 0.6929 minus 1 minus 0.8802. Simplify by the calculator, so you should be getting 0.573. That's going to be the answer. Now coming to the next part of the question, or the next question, question number 5. The arrival times of 204 trains. So n is equal to 204, one noted, and the number of minutes t that each train was late was recorded. The results are summarized below. Explain what is minus t lies between minus 2 and 0. So this is the number of the minutes that the train is late. So between 0 to 2 minutes the train, there were 51 trains that were late. Between 2 to 4 the minutes, there were 69 trains that were late. Between 4 to 6 minutes there were 22 trains that were late. But what does it mean between minus 2 to 0? Minus 2 to 0 in this case, that the time is negative, but the time cannot be negative. It means that the trains have arrived early. The trains arrived early. The trains have arrived early. The negative time cannot be there. So, but it has indicated that they have been early and they were never late. So that is the first part of the question. Now what is being asked? It is being asked, draw the cumulative frequency graph. So for the cumulative frequency graph, first of all we have to find the cumulative frequency table. So we shall find the cumulative frequency table. So let me quickly draw a cumulative frequency table. So the first one is ending with 0 minutes. So it's time 0 minutes. The second one is with ending with 2 minutes. So the second one is up to 2 minutes. So it's not drawing. So let me draw a straight line. Yes, there. The next one is nothing but what, 4 minutes. Then it is 6 minutes, and then it is 10 minutes. Okay. So it is minutes in late, and it is cumulative frequency. 0 minutes, 2 minutes, 4 minutes, 6 minutes, and I am left over with nothing but what, 10 minutes. Till 0 minutes, how many it was? It was 43. Then up to 2 minutes, it is 43 plus 51. 43 plus 51, it is 94. And then 94 plus 69 is nothing but what, 163. 163 plus 22 is 185. 185 plus 19 is 204. So this is going to be my cumulative frequency table. So once I get the cumulative frequency table, what am I going to do? I am going to draw the cumulative frequency graph. For drawing the cumulative frequency graph, I need to go draw it out the x-axis and y-axis. So let me draw an x-axis and then y-axis. X-axis is in minutes and y-axis is a cumulative frequency. So -2, 0, 2, 4, 6, 8, 10. And do I have 50? I have 100, I have 150, and I have 200. So at -2 I take it as 0, and at 0 it is nothing but what, 43, somewhere closer to 50, and at 2 it is 94, somewhere closer to 90. If you draw using a graph paper, it will be much more accurate. I am not using a graph paper, and it is 4, it is 163, just above 150, and it is 6, it is 185, nearer to 280, 200, and finally 8 is not there, and it is 10, 10, 204, 204. So this is going to be the approximate plotting for the cumulative frequency graph. So now we can join it out by a curve or by a straight line. So joining by straight lines is much more preferable. So because of not using the graph paper, if you use the graph paper, you can use a curve as you wish, whichever you are comfortable with. I am drawing with the straight line. So this is almost all looking like a cumulative frequency graph. Now what is being asked, find the median and interquartile range. Median. So I have to find it out the median for this one. So I know that there are 204, n is equal to 204. So for finding the median, so we divide it by 2, so which is 102nd observation. So 102nd observation. So what am I going to do? From 102, draw a straight line parallel to the x-axis and drop it down. So you should be getting it out approximately anything between 2.1 and 2.4. 2.1 to 2.4. Okay, so that's going to be your Q2. Anything between 2.1 to 2.4. Between 2.1, so let me write it out over here, between 2.1 and 2.4 as per the mark scheme, and we are also almost on getting the same. Next we have to find the interquartile range. For the interquartile range, first of all I have to find Q1. So how do I find Q1? Q1 is 204 divided by 4, which is nothing but what, 51st observation. So I have to find the 51st observation. So 51st, just draw a line very nearer to 50 and perpendicular, so it may be coming approximately 0.4. Now I find Q3, which is 3 times 204 upon 4, which is 153rd observation. 153rd observation. So again from 153, draw a straight line. Where is 153? Draw a straight line and drop it down. It is approximately coming it as 4. So interquartile range is equal to Q3 minus Q1, which is 4 minus 0.4, which is 3.6. Mark scheme says that interquartile range should be there between 3.2 and 3.6. 3.2 to 3.6. So we are getting it out almost all correct. That's going to be the question number 5. Coming to question number 6. On any occasion when a particular gymnast performs a certain routine, the probability that she will perform it correctly is 0.65. So probability of success is 0.65, failure is 0.35. Find the probability that she will perform the routine exactly on 5 occasions out of 7. So out of 7 times, I want 5 times success. 0.65 whole to the power of 5 and 0.35, remaining 2 times there should be a failure. So simplify by using the calculator. 3 significant figures, 0.298. That's going to be the answer. Now on one day, she performs the routine for 50 times. So n is equal to, for the second part, n is equal to 50. Now use a suitable approximation to estimate the probability she will perform routine exactly correctly fewer than 29 occasions. So probability of x less than 29. So this is binomial distribution. You have to convert into normal distribution. So what is the thing is, for example, if the binomial distribution is like this, so I draw a block. So I'm trying to draw a block over here, and one more now. So let me quickly draw one more box over here. So for example, this is for 29, this is 30. So I want less than 29. Less than 29 means it starts from 28.5. So you should be able to take it as less than 28.5. So whenever we are doing the approximation, converting normal distribution, binomial distribution to normal distribution, care should be taken that we do this correction. So 29 has to be taken as 28.5. But I need to find mean. Mean is nothing but what? NP. N is 15 and P is 0.65. So nothing but what? The 50 times 0.65, which gives me 32.5. And I need to know the variance also, which is nothing but what? NPQ. So 50 times 0.65 times 0.35. This gives me 11.375. So now I convert that into the binomial distribution into the normal distribution. So Z less than 28.5 minus mean is 32.5 by standard deviation is square root of 11.375. That was the variance we got. We have to use the standard deviation. So it becomes probability of Z less than negative 1.186. We know that whenever we have the less than negative, so we have to convert negative to positive as 1 minus probability of Z less than 1.186. So see from the table 1.0.8822. So that is 0.118. So that's going to be the answer for the second part. Now coming to the third part. On any another day, she performed the routine for n times. Find the smallest value of n for which the expected number of correct performances is at least 8. At least 8. So she is doing it out n times and we should be getting it out at least 8. So first day she is doing it out so what does that mean? So let us see carefully. On another day she performs the routine n times. Find the smallest value of n for which the expected number of correct performances is at least 8. So first time and second time and third time and fourth time and so on till how many times? N times. And at least in the sense nothing but what it is greater than or equal to 8. So at least means minimum it should be 8, so greater than or equal to 8, so at least 8. So there should be two words, at least and at most. If at all it is at least, greater than or equal to 8. If at all it is at most, less than or equal to 8. So first time it is 0.65 and means times. Second time is also 0.65 and means times. The third time is also 0.65. So it's, if at all it's taken like this, so the most common mistake most the students will be doing it out is, if at all I take 0.6565 n times, it will become 0.65 whole to the power of n, which is greater than 0. This is greater than 8, which is an error. So this should not be the way how you should be taking it out. So you have to be very much careful in understanding this question. So n times has been done and each time it is 0.65. So 0.65 times n is greater than or equal to 8. So n is greater than or equal to 8 divided by 0.65. So n is greater than or equal to 12.3. So the immediate number is nothing but what? 13. So you should be taking 0.65 times n, not 0.65 whole to the power of n. So many of the students will be taking 0.65 whole to the power of n, but it's not the case. It should be 0.65 times n, because read the question carefully. He says that on another day she performs the routine n times and each time it should be getting it out 0.65. So 0 point, not it is first day, second day, third day. If at all it is first day, second day, third day, then it is 0.65 times 0.65 times 0.65. But it is on one particular day itself only n times. So therefore it will be 0.65 times n. If it is n days, then it will be 0.65 to the power of n. But it is only on one day and n times. So 0.65 times n. Now coming to the last question, seventh question. Box A, box B. Box A contains 5 red, 1 white and 7 red, 2 white clips. That is a composition of box A and box B. Now what is being done? One paper clip is taken from box A. One paper clip is taken from box A and transferred to box B. So what that paper clip can be? The paper clip can be either be red or white. It can be either be red or white. So red will be, it can be either be red or white. So red or white. If it is red, it will be 5 upon 6. If at all it is white, it will be 1 upon 6. That is from box A. Then one paper clip is then taken from the box B. So when red clip is being transferred to the what it says to the box A, the box B's composition will be changing. So box B will be no more we having 7 red and 2 white. It will be having 8 red and 2 white. In that case, if at all I want to draw red, it will be 8 upon 10 and white will be 2 upon 10. But in case, if at all we are transferring the white to the box B, then in that case the composition will be no more be 7 red and 2 white, it will be 7 red and 3 white. Then in that case the probability of drawing red will be 7 upon 10 and white will be 3 upon 10. So this will be the probability distribution or tree diagram. So you have to draw it out, know the tree diagram carefully. The composition of B will change. If you are adding red, you can see that it becomes 8 red and 2 white. If at all you are adding white, it becomes 7 red and 3 white. Once we are getting this tree diagram correctly, then we can proceed further. Then find the probability that the paper clip taken from box B is red. So we have to take the box B's paper clip, which is red. So how it can be red? It can be red inside this one way. Then is there any another way? And two ways. So probability of being red, it can be 5 upon 6 times 8 upon 10 plus 1 upon 6 times 7 upon 10. So it becomes 47 upon 10. So by what is 47 upon 60? So what I have done it out, I have done the second part first. So we shall go to the first part. Find the probability that the second part has been done by mistake in the first. Find the probability that the paper clip taken from the box B is red. That is the second part of the question. So I am taking the red one. 5 upon 6 times 8 upon 10, 1 upon 6 times 7 upon 10. So that has been done for the second part. Coming to the first part. So what is the first part of the question? Find the probability of taking both white paper clip from box A and red paper clip from box B. So first one, from white from box A and red from box B. Red from box B. So white from box A. White from box A is 1 upon 6. Red from box B is 7 upon 10. So which is 7 upon 60. The first part. The second part, anyway, we have done it out. Find the probability that the paper clip taken from box B is red, which is already been done. Then the third part. Find the probability that the paper clip taken from box A was red, given that the paper clip taken from box B is red. So probability of A red, given that from box B is also red. From box B red is just now we have done it out, which is this entire thing. So that goes to the denominator. After given that whatever is there, that goes to the denominator. After given that we say that it is box B red, so that goes to the denominator. A part of it goes to the numerator. Which part goes to the numerator? A red. So which is A red out of these two? This is A red and this is A white. So A red goes to the numerator. So which is 5 upon 6 times 8 upon 10. So it becomes 40 upon 47. That's going to be the answer. So after given that whatever is there, that goes to the denominator. So after given that box B red is there, so that goes to the denominator, and then part of it goes to the numerator. So a part of it which is A red, so that goes to the numerator, 5 upon 6 times 8 upon 10. So answer is 40 upon 47. Now final part of the question. The random variable x denotes the number of times the red paper clip is being taken. Draw a probability distribution table. So we are taking a, what is this, red paper clip. So because I am drawing two times, because we need to see that first time I am drawing from A and placing them in B, and next time I am drawing from the B. So I am drawing only two times. So I can get either 0 red clip, 1 red clip, or 2 red clips. 3 red clips is not possible because you are drawing only two times. Firstly is from A, placing it in B, and then again directly from B. So there are only two times. So this is x, and probability of capital X is equal to small x. 0 red clips. So this x represents the red clip. 0 red clips. 0 red clips is in, what does it mean, sir? Both are white clips. Both are white. Both are white. So can we scroll up and check the diagram? Both are white. Both are white will become 1 upon 6 and 3 upon 10. 1 upon 6 times 3 upon 10. Then two red clips means both are red clips. That will be easy. Both are red clips. So scroll up and check it out. Both are red clips. 5 upon 6 and 8 upon 10. 5 upon 6 times 8 upon 10. One red clip, just now we have done it as was one red clip. So if we want to do one red clip, what we can do it out is, we can just take this as 3 upon 60 and this is 40 upon 60. So sum of total probabilities is 1. So this is already 43. So remaining it has to be 70 upon 60. So 60 minus 43 is nothing but what? 17 upon 60. So I got the probability distribution table. So in this way, I can get the probability distribution table. Very simple. So this becomes, let me write it out finally, 3 upon 60, 17 upon 60 and 40 upon 60. Or one red clip, if at all you don't want to do by this concept, what you can do it out is, you can just check it out, one red clip. So this is red, so it has to be white, 5 upon 6 times 2 upon 10, and white and red, 1 upon 6 times 7 upon 10. You can see one red clip will be 5 upon 6 times 2 upon 10 or 1 upon 6 times 7 upon 10. So which is going to be same, 17 upon 60. So in this way, we will be getting the probability distribution table. So that completes the paper. See you in the next paper. Bye for now.